Ready, set, go. Alright, today we're going to talk about types of suspension. Again, we're in chapter 29. We have a solid axle system that provides means of mounting a hub and wheel, and it's non-independent suspension, as you can see here. It has leaf springs, a couple of shocks, non-independent. Dead and live refer to whether the axle is a driving axle or not. Dead axles holds wheels in a proper orientations, and live axles can be non-independent or independent type suspensions. Drive axles is because it drives the wheels. Independent suspension allows wheels on each side of the axle to move up and down and independently of each other. The most common is the Mcpherson Strut. That Mcpherson Strut suspension, dubbed Mcpherson Strut suspension. This is what they usually look like. SLA suspension system, a little bit more complicated. SLA stands for short long arms. In strut suspension, the shock absorber is contained inside the strut. As you can see here on the top right is a Mcpherson Strut. And the coil springs are located in between the shock itself. SLA suspension system, coil springs can either be mounted from a lower control arm, which is type 1, or between the shock towers and the upper control arm, which is type 2. The coil springs can be mounted in two ways. You can see here A and B. Between the frame and the lower control arm was type 1, and between the shock tower and the upper control arm is the type 2.
So what type of vehicles typically like that? Or what company preferably uses those in a vehicle?
It really just depends on the application of the vehicle. Steering knuckle is mounted at the ends of the control arms by ball joints, and it has it on the short and long knuckle. You remember the little ball joints like Lombato's truck in the bottom? That's a long arm on the bottom, the lower control arm, which has a ball joint. Had it was SLA too, isn't it? Because we had short arm on top, and it also had a ball joint on top. You guys had to remove that to even get to the lower control arm. Steering knuckles, different types of steering knuckles. What? Long knuckle SLA. Oh, I see what it's talking about. So here's one that's it's part of the knuckle. I forget which mouse it is. This one is really long, and then you have a short one, right? This is part of the steering knuckle. Short. The tween I-beam suspension is independent suspension that uses separate I-beams for each front of the wheels. It is supported by a coil spring to support the vehicle. This is application for like big trucks, diesel trucks, even F-150s, some Silverados, things like that. Just larger trucks. It's heavy duty. Rear suspension, its main function is to keep the rear tires in contact with the road and alignment with front tires. Rigid axle leaf spring suspension can be used in both the dead and live axles. Rigid axle coil spring suspensions cannot provide any side-to-side or front-to-back stability to the axle. Well, we have lateral arms. I keep grabbing the wrong mouse. There we go. Panhard rods are used to control the lateral forces. Like if it had spring coils, the spring leaf springs on them, those control the lateral side-to-side movement. Since this doesn't have those leaf springs, they don't have leaf springs. They use the lateral control arms to hold it in place. Or a panhard rod. Panhards or panhard rods, or even Watts linkages. These control the lateral movements of this wheel from going side to side. Keeps it centered. In rigid non-drive axle suspension, longitudinal and lateral positions of axle must be maintained. Again, they're showing the pan rod. Rear independent suspension on non-drive can be simple because wheels don't typically steer or drive the vehicle in any way. On the rear-wheel drive vehicles with independent rear suspension, the final drive unit is fixed to the vehicle's frame. Each drive shaft must have a spline section and can move in or out to vary shafts lengths. Torsion bars, I believe that's what they're talking about. Drive shafts can be used as an upper link of suspension, providing an upper pivot point. I think the video explains this because I don't get this picture at all. Like what? Adaptive air suspension is an electronic control system. Its vehicle suspension's height remains constant. Its adjustable damping ride height are maintained by single processes. The driver can influence the suspension characteristics and operating dynamics. ECU compares information control systems to reference value and activates either electric motor or compressor or exhaust manifold valve. Computer controlled suspension use computers to constantly monitor all aspects of suspension system and ride height features. Only in active systems though. It can be either hydraulically actuated systems, electromagnetic or rheological systems, semi-active systems, solenoid valve, and stepper motor actuated systems. Those high-end vehicles like Land Rover, Range Rover.
On front-wheel drive vehicles, a simple beam axle can be used on the rear with coil spring suspension and control arms for fastening. This is called a dead axle since it only supports the vehicle and doesn't transmit any drive. It is also non-independent, as deflection of a wheel on one side of the vehicle will be transferred to the other wheel. On some vehicles, this is reduced by using a U-shaped axle beam with a torsion bar mounted inside it. Trailing arms are welded to the beam to fasten the axle longitudinally. A lateral rod prevents lateral movement while cornering, and coil springs provide for suspension. The torsion bar is connected between the left and right wheel units, and deflection of the wheel on one side causes the axle and its torsion bar to twist together. Passenger cars no longer use beam axle front suspension, but it is still common on heavy commercial vehicles and some four-wheel drives. Trucks use an I-beam, in most cases fastened by leaf springs. Four-wheel drives with rigid axles may use leaf springs for front and rear suspension. Coil springs may also be used for front and rear, and as with other beam axle designs, control arms and a lateral rod must be used for fastening.
One of the main benefits claimed for an independent suspension is that unsprung mass can be kept low. Also, if a wheel on one side hits a road irregularity, it won't upset the wheel on the other side of the same axle. And it allows wheel chambers to be adjusted individually when provided for by the manufacturer. One of the simplest and most common independent suspension systems is the Mcpherson Strut type. It can be used on the front and rear of the vehicle. It consists of a spring and shock absorber unit called a strut. The lower end of the strut is fastened by a ball joint, fitted to the end of the suspension control arm. Its upper end is fastened in a molded rubber mounting. If the unit is on the front, the upper mounting includes a bearing to allow the complete strut to rotate with the steering. A tension rod, or stay bar, extends from the body subframe to the outer end of the control arm. This maintains the fastening of the control arm during braking and accelerating. In this front-wheel drive suspension, the control arm is a wishbone shape with two widely spaced mounting points. This prevents backward and forward movement, so a tension rod is not needed. Wishbones can also be used in a parallel link system. They can be used in pairs with the coil spring between the lower wishbone and the suspension crossmember. Alternatively, the upper link may be a wishbone with the coil spring mounted above, combined with a single pivot lower link fastened by a tension rod. On some vehicles, a torsion bar provides the springing medium. Torsion bar is attached at the inner fulcrum point of the wishbone or control arm. As the suspension is deflected, it twists around its center. It can be fitted to the upper or the lower link depending on the type of vehicle. The upper link is shorter than the lower one, regardless of the springing method used. When the suspension is deflected, unequal lengths allow the track of the vehicle to be maintained near constant, but with some changes to camber angle. Generally, when the car leans during cornering, the inner wheel leans outwards at the top, and the outer wheel leans inwards. This helps to maintain maximum tire contact with the road surface. A number of different layouts are used in front suspension systems, incorporating either a driven or live axle or a non-driven or dead axle. This independent driven or live axle front suspension arrangement consists of coil spring, lower wishbone, and Mcpherson strut. This arrangement consists of coil spring, strut, tension rod, and lower control arm. This non-driven or dead axle front suspension arrangement consists of coil springs, lower wishbone, and upper wishbone.